This video shows the automation of data retrieval for stored procedures and tables or views containing specific parameter values and column values. As you might realize, SQL Server Management Studio can be used to retrieve data and execute stored procedures, but unfortunately, it cannot dynamically provide input parameters for other SP or tables/views as a result of executing a specific SP. Because of this, it's very hard to keep track of what stored procedures you execute with what input parameters. There are two scenarios in which SSMS can be used: to use new query window for each stored procedure or script, or to use a new query window for multiple stored procedures and scripts and execute them by overriding their parameters. As you can see up to this point, it is hard to keep track what you execute and in which window. It is not to mention that there is no information about what that SP meant or what the columns of specific SP meant, especially in the case of SP1, which returns multiple result sets from multiple tables. Also, sometimes we want to retrieve data from specific views or tables with filtering based on specific values or time range, which when using SSMS requires a lot of copy-paste operations. In other words, the number of operations the DBA has to perform to obtain the result set increases. Up to this point, I performed from 10 to 20 operations of copy-paste type, and some typing to filter the data while working with SSMS and the SP and tables I needed. The solution to these shortcomings of SSMS, and a way to greatly improve the productivity and the outcome of DBA work, is to have your own implementation of TSQL script execution and the way you consume the output, which is presented in the next 4 minutes. The solution is to address all the shortcomings and improve the productivity by having your own graphical user interface, which will create a tab for each instance for which you want to execute scripts. For each instance, it will create a tab for each script that was executed on that instance, and will keep all the result sets obtained. So first thing is to add a new instance. Provide the parameter name for which we want to execute SPON, which is a stored procedure which outputs values which will become input parameters for all the other stored procedures and tables or views. Once SP1 is executed based on the input parameters and column names for all the other things, we usually execute the code for those will be updated. So the benefits of add new instance is that first we will have access to the help of what each SP means and what each table might mean. Once SP1 is executed, we transpose the result sets and we add column meaning to each column from the result set, which is very helpful when you want to remember something or understand what service level might mean or block size. These are just examples. On top of adding column meaning, the execution of SP1 made all other procedures which were expecting values for parameters in the output of SP1 ready for execution. In this moment, we can check the code generated and run the execution of the SP or select statement from specific view and / or table. For tables and views which have a date-time column, we employed a visual aid for filtering them using a start date and end date based on the date-time column we selected. There is a hard-coded check which will not execute the script if we return data for more than 48 hours, but of course this hard-coded value can be changed based on the amount of data you might have in that table for those filtering options. Each script execution will have a name, which is a combination of timestamp, stored procedure, or table name, and in some cases, the input parameters. Once we have the result sets, we might want to search them or share those result sets or part of the result sets or to compare those result sets. Searching capability allow us to find specific scripts executed against specific instances. In other words, it help us to find or to see what we executed more easily. Although SSMS have display horizontally and vertically for result sets, and you can modify the select statements to return only specific columns, I believe DIMS approach of using multiple grids in which you can display specific columns and increase specific data grids is more appropriate when you want to put side-by-side specific columns and share them to make a point. Same approach, meaning the way in which we select which columns we want to display in multiple result set tab, can be used if we want to merge result sets that have been obtained using same script for different instances. Any of the result sets obtained can be added to the main application, and when there we can use all the other features of the application. I choose to chart some data obtained. Of course, that since all the information is in the memory, we can display a log of operations we performed. For example, we can add a button which will export to a text file all the script names and the code we executed. If 25 rectangles are not enough because we use more than 25 SP in tables to do our job, then we can add more rectangles and group them, and add an option next to clear search, which will jump to specific rectangle in order to make them visible without the need of scrolling and searching them. Since we have control over the interface, we can add visual aids to each rectangle to let users know which stored procedures are retrieving data and which ones are updating data. Having control over the graphical interface you are using to consume your data allows you to implement all sorts of automation and improvements.